Preceding chapter. Probabilistic reasoning. Okay, so this entire chapter is about uncertainty. So what is uncertainty? Consider we have an example. If A is true and B is also true, we can say that A implies B, where the situation is certain, we know that A is also true and B is also true. Right? So in other case, we are not sure whether A is true or false, but B is true. Okay. So in this case, what we can say? So the situation is uncertain because we are not sure whether the A value is true or false. Right. So this entire chapter it is about uncertainty. So and in case if they ask what is probabilistic reasoning, what you can say? It is a kind of representing the knowledge using the probability, right? But like by taking this conditional probabilistic tables as the main agenda. So this table, conditional probabilistic table, will be used to represent the probability of whether the incident has occurred or not. Okay. So why we use this probabilistic reasoning? So it is a kind of knowledge to represent the uncertainty or the probability indicating the uncertainty, how much uncertainty it has happened in that particular incident. Okay, so to indicate that uncertainty, we'll be using the network called Bayesian network. Right. So what is this Bayesian network? Bayesian network is a directed graph which will be followed with the quantitative numbers. Right. So for each and every node, there will be a number or there will be a value which will be associated for that direction. So consider we have so to make a network, to get a network, so we should follow three condition or three characteristics. So the first one is what will be the first character which we have to follow? So each node corresponds to a random variable. So for every node there should be a variable, right? So this variable can be discrete or it can be a continuous variable, but the nodes should be associated with the variables. And then, so consider we have x, which implies y. So when a node x is implied with a node y, so we can say that x is a parent node for the y, right? So what this sentence will, what this statement will say? So there should be a directed graph which will represent a parent in that particular graph, right? So the directed links between two nodes should be there. So what will be the third one? The third one, so in case, this Bayesian network is a directed graph, but thing is, if there will be no directed cycles. So we call this Bayesian network as directed acyclic graph. Okay. So the third one. What is the third one? So now each node X side has a parent node, right? So for this we will be writing a condition which is the probability of Xi implies the parent of Xi. So for every node Xi, so there will be a parent node X, right? So these are the three characteristics which we have to follow. So to consider the example, So we have considered the three four variables. So one is weather, and one is cavity, and cavity implies toothache. And the catch. So toothache का catch होगा, cavity का catch होगा. हाँ? So is there will be any catch in a, like when we get a toothache or when we get a cavity, but in your textbook they mentioned toothache and catch will come from cavity. Okay. So they are saying this cavity is a directed graph or direct relation with this issue which will be directly which will directly leads to toothache or a catch. But there is no direct relationship between the toothache and the catch. Right. So these two are the conditional probability nodes, probabilistic nodes which are dependent on the parent node cavity. Right. So what about this weather? Weather is dependent. No. So it is an independent node which is not dependent on the cavity. Right. So in this graph they are saying it. So these four are the variables where the weather is independent of the other three variables, and so this cavity is the direct cause for the toothache and the catch. But this toothache and the catch, in between that there is an absence of link, which is like these two. When we write a table for this node for this graph, so for this cavity, we can say only the probability of CRK, which will be like, consider we have got a probability of 0.08. Okay. So this is the probability which is saying P of Q. If it is P of, like if it is false, so what will be the value? So this will be 1 minus P. 1 minus P, this is 1 minus 0.08. So whatever the value we will get, so that value we have to write it here. So if the statement is the P of cavity is 0.08, the negation of that will be 1 minus 0.08. So in here for the toothache and catch, so since it is having a parent node, so this truth table will be P of C, P of L. Okay, so whatever the answer will come, so that we have to write it here. So this is true, false, and false. Okay, so Okay. So this is an example which they will be using for entire chapter. So what is this example? So there is a person. Who is that person? Karthik is a person who have installed this burglary alarm in his home. Okay. So beside his home there are two neighbors. One is John and one more is Mary. Done. So what this John and Mary will do? So in case if the alarm rings and if Karthik is out of station or he went to office or he came to college, so that time this John or Mary should call and inform that there is a burglary or there is a earthquake. Done. So, but the thing is, John will always get confused with the telephone ringing and the alarm sound. So he will miss the call. And Mary is like she likes the loud music. So because of that, she will always miss the alarm sound. That kind of neighbors Karthik is having. Done. So now, uh, so what are the probabilities that they can get? So John can miss and Mary can also miss. So there, these two are only the possibility to get a car right to the casting. But these two are also a probability. It can happen or it can never happen. Right. So what about this alarm then? Alarm will also go. It can also go off because of like humidity, high humidity, or power cut. Or in case if inside this alarm some cat or rat went inside and it spoiled everything, right? So there are many possibilities to fail. There will be no alarm also, right? So in this condition, whether this machine will work or not, so that probability, all these are uncertain only. So we cannot say it is certainly. So John will call and he will confirmly inform us that there is an earthquake. No, right? So all these are uncertain conditions. So these uncertain conditions, so they will be using for entire chapter to prove how that possibility will work. Okay. So here also, if we have if this alarm is having the parent node, right? So the burglary and the earthquake is the parent node. So for this alarm, the truth table will be 2 to the power of k. Okay. So since the alarm is added to parents, 2 to the power of 2 is 4. Right. So it will be something like true, false, false, true, false, and false. Right. So the probability from burglary and probability of earthquake, it will define the probability of alarm. Right. And what about this burglary? There will be a probability of true. Right. If it is true, consider the value 0.001. And what about the probability of false? It is 1 minus p. 1 minus p in the sense 1 minus 0.01. Right. So like this, we can define the probability for the all the conditions, for all the variables. Right. So in case, mm, so for this network, if we are saying how this Bayesian network will work, so this is just a probability, right? So in case if we consider the semantic Bayesian network, so in this we will be dividing into two types. One is joint distribution, conditional probability, and one more is conditional dependency probability. Okay, so two kinds of distribution we can see: joint probability distribution, conditional independence distribution, right? So in that first one is the full joint distribution. So how this full joint distribution equation can be written? So here we have the parent by P of xi implies parent Right. So this is a true statement which we will be following for every algorithm. The thing is, in this full join, if this probability is replaced with number, any number, you can write this formula as theta of xi implies parent of xi. Right. So, and if we assign any values at any condition, so we can write it as P of xi equals to xi, x1 equals to xi, x2 equals to x2, till xl is equals to xl. Right. So for this parent value, if we are writing like this, so we can define it in the way P of x1, x2, xn, which is equals to sigma of I equals to 1 till n theta of xi plus parent of xi. So this will be the probability if we are replacing this statement with a number. So this was the probability which we are saying. But in case if we are replacing the probability statement with a number, so we will be replacing the theta value, right? So the remaining the xi plus parent xi is same, right? So in case if we are assigning any values to the any of the node, so when we have assigned the value, so the x1 value will be some value of x, right? So x2 will be value of x2, and here xn we are assigning, right? So that we can write it in the form of p of x1 comma x2 till xn is equals to sigma of I is equals to 1 to n theta of the same xn parent of xn, right? ಎಲ್ಲ ಸೇರಿ So consider John and Mary are calling. Okay, once the alarm is ringing, but that means like these two persons are very attentive, and this burglary and artifact is it does not happen. So how can we write this variable if we have to write it in this way? Consider this is B, E, and J, M. This is A, right? So John is attentive, yes, comma. Mary is attentive, comma. Alarm is also working fine. But the thing is, there is a negation of burglary and there is a negation of right. So this is how we will write if they give a condition. They have if they have said like John, Mary, and Alaram are very attentive, so they are working fine. But the thing is, when there is a fail in burglary and artifact, how can we write the variable?